Hoi, let's have another example of a category. So this time I want you to think of your favorite monoid, and let's call it M. And I'm going to turn this monoid into a category for you. So the idea is as follows, that we take our monoid and then we're going to make the objects of this category really boring. To say that the objects are exactly the one element set. So I only have one object over here. But I'm going to make the morphisms interesting. So I'm going to say that there is a morphism which necessarily has the same source and target. There is only one for every element of my monoid. Right? So if I have my monoid is the natural numbers, then I have a morphism for 0 and a morphism for 1 and a morphism for 2, etc. So I'm making my morphisms interesting. So there's only one element, and saying that this is the carrier of the monoid. And then I need to say how to compose these morphisms, and I'm going to do that by using the multiplication of the monoid. Right, so that gives me a composition, and then my monoid has a unit, so that's going to give me the identity for this composition. So let's see if we can do this in Agda. So you have given me a monoid M, I'm going to give you a category. Okay, so I said that this object is trivial, and here I want to use the carrier of the monoid. So I have to first take two things I don't care about. So these are the morphisms from blank to blank, where blank is the only element up top. Right. Okay, and then I have to give an identity. That's going to be the unit of my monoid. And I have to give a composition. That's going to be the multiplication of my monoid. Right. Okay, and then here I have to show that my composition is associative. It's a bit hard to read, but this is exactly the associativity of the monoid. Right. And similarly here, I have to show that if I multiply f with the unit, then I get f. That's exactly the identity of the monoid. I think it's swapping left and right here. And similarly here on the other side, it's the identity on the left. Okay, so we see that if you have a monoid, then you have this quite boring from the perspective of the objects category, but quite rich from the perspective of the morphisms. Or put differently, you can see a monoid as a kind of untyped category, right, where you have all these different morphisms going around, but they all have the same source and target, so they're all composed with each other. Whereas in a category, you can't compose every morphism with every other one, right? You can only compose them if the source and target agree, like this for these two, but you can't actually compose this one and this one. So in that sense, a category is a more refined notion of a monoid.